Electrical Inspector Department of EMA. Now, as you know, the interview is the last step to become an LEW. Some of you are getting nervous and don't know what to ask you in the interview. So don't worry, this briefing is to help you so you will understand what they expect from you during the interview. But first thing first, let me clarify a few myths in the industry. Some people ask me, EMA, very nasty one. Always a quota for EMA licenses. So once the quota is reached, I cannot be an LEW. Some people ask the questions the officer ask me, very difficult and impossible to answer. But let me just clarify this. There's no quota. Of course, it's clarify to me, there's no quota in our system. In fact, we welcome all of you to become LEW. As long as you are competent, you can discharge your responsibility. We welcome all of you. Some questions you say, oh, it depends, it will be difficult. But the questions we want to ask you is to make sure that you have the ability, you have the competency to be able to discharge your duties responsibly. Now, being an LEW is not easy because you're dealing with electricity. We all know electricity is invisible. You can't touch it. You can't smell it. If you touch it, it can be very dangerous. To handle it properly, there will be life and death issues. And on top of that, if you are LEW, you encounter some of your clients, they may want to prioritize cost. Cost is important. Safety doesn't matter. Even your workers want to work with you. They may not follow the safety procedures as much as you want to do. They may want to take some shortcut do the work. So as an LEW, you take very high responsibility. You must be not only competent, you must be very calm, you need to be under pressure, you have to be very composed, you have to be very careful to deal with electrical installations. So at the end of the day, after you become LEW, I want all of you to be able to go home safely. And also the installation that you are taking charge are safe also. That is very important. Now, some of you think that LEW is a quick way to get rich. Again, it's a myth. Or some of you will think that, oh, LEW is a recognition. I worked in this industry for so long, I'm very good, so I want to become LEW. I collected a lot of certificates, O-level, N-level, IT, marriage cert, wealth cert, I collect already, so I need one more LEW certificate. But LEW is not a certificate, it's a license. It's a license of a lot of hard work. You need to pay a lot of attention to the competent in your time, you're competent in your inspection, your testing, your operation, your repair. You take charge of installations, and you have to go out in hot sun, working in an environment. It will not be a very cozy environment. A lot of hard work is required to become LEW. So I would say, we want our LEW to be able to discharge the duty very well and very composed during the installations. Now, once you become LEW, you take on a very high responsibility. You know that as LEW, we expect you to be able to endorse, to sign a document, and that carries a lot of weight. You sign that the installation is fit for turn on, is safe for operations, that carries a lot of weight. Your clients trust you, EMA trusts you, because of the inspector found that it is safe for operations. And for that reason, the power company will turn on. That carries a lot of weight, a lot of responsibility. But at the same time, if the installation is found to be effective, the design is found to be wrong, you will be liable. You will be prosecuted. So it carries a lot of responsibility. do is, I will tell you what EMA expect, what we expect you to know as a learner. These are important topics. So before you come here, you can learn it up, find it from your friends, get yourself well prepared for the interview. Alright? Okay, you all ready? Okay, let's get started then. Now, there are some applicants for electricians, there are also some applicants for technicians. So, if you apply as electricians, you'll go through 2 steps. One is a practical test, then followed by interview. Right? So, for those who apply for technicians, there's only 1 step. So, you can go straight to the interview. Now, for the electricians, you'll be given a board. Similar electrical installations, where there are some faults built inside the installation. The fault can be open circuit, short circuit, maybe there are wrong polarity, things like that. So, with the instruments, you're supposed to troubleshoot and find out what are the faults in the installations. Right? Now, what do you want to bring inside into the lab? Bring about multimeter, continuity meter, will be good enough. Bring a screwdriver because you need to remove some screws and so on. Just simple Phillips screw or flathead screw is enough. Well, it's okay, right? So once you pass the test, it means you are able to troubleshoot the faults in the electrical installations. Then you proceed to the next stage. The next stage is an interview with officers who will ask you some questions and you move on from that. So the interview sessions are cover both electricians and technicians. Of course, in terms of depth of the questions that you ask are different because electricians you can really design to 45 kVA, whereas for technicians you can be in charge of high installation and so on. So the kind of questions that you ask are different, but I will just highlight what are the topics which are important to us. Now, I'll briefly highlight a few topics which are important. One is the design of electrical single line diagram. Second, protection from electrical safety. Thirdly, earthing and bonding. Fourth, testing and commissioning. And finally, there are some questions on temporary installation, etc. Now, these topics are not comprehensive. These topics are important topics. They are, you can find some of the answers to these topics from simple standards, some of the code practices. You're not so sure, you can ask some of your friends or colleagues. You will get the answers, but they are not comprehensive. There are maybe some other which are equally important, but I can only cover so much into these sessions. So let me firstly talk about design of electrical single line diagram. So in the interview, you'll be asked to prepare a single line diagram. Now, single line diagram is very important that all of us know. This is how you express your idea. You have an idea of how I want to design something which is very reliable, very powerful, things like that. How to express it, how to show it to people who execute the work, or someone is designing, how do you know how to interpret the design to execute properly? So the electrical single line diagram is something that all of us have to understand. So you comply with the same standard CP83. So don't draw a box and expect us to see circuit breaker. So we follow the symbols from the CP83. We know this cross or this symbol represents circuit breaker. But this symbol represents a current transformers. Because these are universal language. This is the CP83. All of us know because we comply with the issue. So we know the standard. So in the single line diagram that produced during the interview, please follow the CP83 standards. What you need to show in the single line diagram, the number we need to show is that what is the type of rating incoming switch here, whether it's a circuit breaker, we use fuse, or we use MCB. You need to show the rating, what is the current capacity, what is the breaking capacity, and some protection devices. For example, you want to have some kind of protection relay, or you want to have some LCCB. What are the protection requirements that you want to put inside this single line diagram? So the one who execute the work or the one who read the drawing knows the design intent, knows what is going to be installed actually. So it also will show what the whole going, say for example, whether it's going to an isolator, whether it's going to an equipment, whether it's going to provide some lighting, some socket outlet, etc. Show it in the single line diagram. What are the rating of photovoltaic circuits. What are the instrumentations? Whether you have power grid meter, whether you have some other ammeters, voltmeters, kilowatt meters, power quality meters that we have, showing the similar diagram. And what are the sources? The sources not only from power grid, you may have standby sources from generators, and nowadays you may even have solar PV, other sources. Why is this important? Because you do not know the sources to the installations. You do not know how to isolate, which we will talk about later on. Isolation of all sources of supply is very important because we want to talk about installation safety. So show all kinds of sources of supply to the installations. Now, finally, type of earning. The type of earning will affect the kind of protected device you use. It all depends on whether you're using a TNS system or using a TD system. In Singapore, we are lucky we don't have IT or TNCS or all complicated systems. We only simple system, TNS, TD systems. But this is important because the way that we design the protective system, it depends on what kind of earning system it is. Okay, now I'll go to the main topic. This is, I would say, one of the most important tasks that we do as an LEW, protection for electrical safety. We want to make sure that we are safe, the installation is safe. All this can be found in SS628. You can see this is something that we need to know. As an LEW, SS628 is a mandatory requirement besides the 650, Part 2. 638 covers all the electrical installations. And out of all these chapters, I would say Part 4 is one of the most important part that we need to pay attention to. Now, in Part 4, we cover two main topics. One, protection against electric shock. So we know electric shock is important. We want to make sure that we ourselves are safe. We want to use electricity is safe. So protection against electric shock. So the Part 4 gives us a lot of ideas how to protect. Second, protection against thermal effects. Thermal effects could be fire, arcing, overloading, overheating. So again, we don't want using electricity into arcing, into fire. So chapter 42 talk about how to protect against thermal effects. In chapter 43, we talk about protection against overcurrents. Because you want to use electricity safely, you want to overload it. So you need to size the installation properly so that you will not be overloaded. When it's overloaded, there are subsequent effects like fire, so we want to make sure that our sizing, our selection of equipment are properly coordinated and no overload. Now let me spend time on this electrical safety. Again, this is very important. Read up chapter 41, in addition, section 131.2, talk about protection against electric shock. Now, what is electric shock? We hear this term very often. Sometimes we think, oh, electric shock. In some cases, people die because of electric shock. What is electric shock? Electric shock is basically a physiological effect. Sometimes you touch something, reflex. You get a shock because of electric shock. Sometimes our finger feel numb. Those are cases in life. Electric shock can be fatal. People die because there's a passage of current flowing through our body. If this passage of current is high enough, strong enough, it doesn't kill. So, in order to protect against electric shock, according to 638, it's very simple. We say hazardous life paths must not be accessible. Now, what does it mean? It means that if there's any life paths, cannot be touched. It's simple as that. So that's why our wires are all insulated. Bus bar can close. It's all shielded. You can't touch it. Not accessible. So that's the purpose of protection against electric shock. This is the direct electric shock. Now the second part of it is that accessible conductive paths must not be hazardous life. Now what is conductive paths? So you read the 638, they talk about exposed conductive paths, extraneous conductive paths, which may include some of the trunking, cable tray, water pipe, water pipe, because all these are conductive paths. So we have to make sure that conductive paths cannot be hazardous life. It means that even its life, it cannot be hazardous. It must be able to keep within a very short period of time, very low energy.
current flow through. What do we need to do? As a LW, we must make sure that the magnitude of the current flow through the body is minimum, as low as possible. Number two, the duration must be as short as possible. So these two factors are important because the duration of the current and the magnitude of the current will affect how severity the potential is. We keep it as low as possible, as short as possible, then the person will be able to survive. The person will not be subjected to fatal electric shock. So that's the whole idea of protection against electric shock. So how do we do it? So say as I talked about under the chapter 41, some clauses we can go into details later on. 4.6.1 talk about installation of line parts, which I talked about experience. PVC sheeting, PVC insulation, cover the conductors so that they can touch the conductor, they can handle the conductors, right? So this is protection against line parts. You also have barriers and closures. So your DB, your switchboard, they're all fully enclosed so that you will not be able to touch. Okay? That's where the IP2X comes in. What's IP2X? You can find out from 638. Prevent fingers from touching line parts. So these are protection against basic protections. Now, on top of that, there's this fault protection. Now, fault protections is a bit more than basic protections. Fault protections means that when there's a fault, the fault must be cleared automatically. The problem is that you don't know when the fault will occur. The fault can be today, it can be tomorrow, it can be 10 minutes later. So how do we know? So whenever there's a fault must be detected and cleared automatically. So the keyword is automatic. Now, how do we ensure that it is cleared automatically? Under the 6th grade, there are three important requirements. Number one, we must have protective earthing. The next thing is to be earthed properly. So later on, I'll elaborate more about earthing. Earthing is important to make sure that it is earthing so that the fault will be cleared in the shortest possible time. Next, bonding. Training conductors, exposed conductor parts, they must be bonded. This is to ensure that the touch voltage is minimized as low as possible. So to fulfill the two requirements I talked about, the duration and the time. We want earthing and bonding work together to ensure that the duration, the magnitude is as low as possible. And thirdly, we still need to cut off the supply. Earthing and bonding, how to cut off supply. So you must have a protective device. This protective device can be MCB or RCCB or relay, fuses, whatever. There must be a device that can detect fault current and once it exceeded a certain magnitude, cut off the supply. So, automatic disconnection supply is described very detailed. Section 411. And under 411, we realize there are two types of subdivision, 414, 415, because it depends on the type of building system. So TNS, there's certain requirements. TT, there's also other requirements. So there's slight difference. So you apply kind of protections based on the requirements. So we will also talk about what is the maximum duration. I say talk about the duration. What's the maximum duration of time? So there's the final circuit, distribution circuit. There's also a time limit specified in the 6th grade. We tell you what is the maximum time which is allowed so the person can be safe. Right? So we talk about the touch voltage. Some of them know what we mean. So we go to the touch voltage. So how do we use the touch voltage to work out? So to face that, we set protective devices to make sure the device will operate the time of the block. Okay. Next, there will be a combination of these fault protections. These are important, especially in those special applications. For example, the swimming pool. For example, the bathroom, where there's a shower, bathtub, etc. So you need basic fault protections in the code described in 4 installations, in 412. These are usually found in appliances and so on. But in 413 and 414, we talk about electrical separation. Electrical separation is important, especially in special environments. When the body is wet, resistance is low. So special attention is paid to make sure the person is still safe. So there's this SDLV, which is a separated electrical source, to make sure that the voltage is low and there will be no chance of electric shock. So in the chapter 41, 43, 44, we read together with chapter 701, we talk about the location contain bathroom, contain swimming pool. Now, the next important thing that we protect is against thermal defects. As I say, when the electrical wires are not properly designed, overloading, there will be fire, there will be arcing. If the design is not done properly, arcing can lead to fire. So, in the 638, chapter 42, also in section 131.3, it talks about how to protect against thermal defects. So basically, there are two sources. One, the source is from the electrical equipment itself that causes fire, that causes electric burns. For example, we have our wires which are heated and current flows through. For example, our switchgear is hot. Our transformer is hot. And transformer is worse because transformer is flammable. So under 638, we also talk about how much flammable liquid we should have to make sure that even though there's arcing, it will not spread. It's difficult to fight the fire. Right? So the other source is external. It's not part of the demonstration from the spotlight. Some of you old enough, you remember there's a very big fire in Windsor Castle many years ago. What's the source of that fire? It burned down Windsor Castle. Imagine Windsor Castle is burned down. The source of the fire is a spotlight. So the source of the heat can also be external. So how do we make sure that if there are heat sources from external, we will not propagate the effect of electrical distributions? So we could talk about in 421, how application against fire caused by electrical equipment. 422 talk about when there are particular risks. For example, if you have escape routes, places where people evacuate during fire, and that's where the place where the fire occurred. It's not correct. So where there are escape route, exit staircase, etc., that's where we should protect against occurrence of fire. And how do we select? This is described in 527 as well as 532.1. So selection of wire, one easy one is the use of fire as a cable, FR cable, RCC cable, etc. And also, how do we prevent fire? You might use RCC, it will help, but it is not a way to prevent fire. It says that it may help, RCC can also help in a way to prevent occurrence of fire. Now, the next one will be protection against current top-up, electric shock, top-up thermal effects. The next one is overcurrent protections. I think this one most of us are very familiar. Overcurrent can be overload, can also be a fault. Overload means that the circuit is healthy, nothing wrong with the circuit. It's just overloaded. You plug too many equipment onto the circuit, it's overloaded. You put too many things on the machine, overloaded. But once you remove all these loads, it's okay, it's back to normal. So, under overload protection, it's still a healthy circuit. You don't need to repair the circuit, you don't need to do anything about the circuit. So you need to remove the overloaded equipment. So, that waste of it, the stress and the cold. The second part is protection against fault current. The fault current can be short circuit. So, this is something goes wrong. That means your insulation has failed. It causes a short circuit between live conductors. So when there's a short circuit, the magnitude of the current is much higher. Overload not wrong, slightly above 100%, 120, 150%, 200%. But short circuit can be many times, 400%, 500%, few times more than overload. So the code does describe different ways to manage this short circuit as well as overload. So this formula, I think most of you are familiar. But don't worry, we won't ask you to do calculation. This is not a session for IT examiner. This is not an examiner. So we would want you to understand the principle behind the formula. What's the principle behind the formula? There are two letters we use, IN, ID, IC. ID is basically a design current. We know there is a maximum demand, that means under the maximum load condition, this is the current that will flow. So in order to make sure that there is protection against overcurrent, our device, our protective device, must be higher than that. That's why IN, which is the rating of the protective device, must be higher than your maximum current. Now, if the cable needs to be protected, then the IC, which is the current capacity cable, must also be higher than IN. Of course, we go further and say that okay, sometimes you need overall protection. Because if we have overall protection for the motor, then you can change the formula because you don't have to afford the overall protection. Generally, for most of the circuits, you need to know that the maximum design current should be less than your current rating of the protected device, should be less than the current capacity of the cable. So the cable can carry the current continuously because the current capacity is higher than the maximum current in the circuit. So this is again is a very typical characteristics of a protected device. This is a circuit breaker. Of course, we still use fuses. We can have different characteristics. MCB generally have this thermomagnetic characteristic. Thermal means there's the overall reactions. Magnetic means there's a fault current. We want to clear the fault as quickly as possible. So with this thermomagnetic characteristics. So in this protection against short circuit, talk about how to protect against short circuit, how to also protect earth fault. Earth fault, in fact, is more common. Whenever there is any fine conductor which is connected to the earth, this earth fault is operate the protective device, trip off, and make sure that people are safe. Now, all these need to be coordinated. We do not have one device. We have a number of devices and installations. In the same circuit, we also have no amount. MCB, we have upstream, other NCCB, for example. So all these need to be coordinated. You may even want to use fuse, depends on the installations. Of course, the company asks to tell you if the fault level is afforded by backup fuse, probably you can do a fuse protections. So what are the devices that we use for protection against overcurrent? This common nowadays, MCCB, MCB. Sometimes when we use fuse, this is possible. We go to larger installations, we need ACB. So these are the devices we can use for overcurrent protections. Now, the other thing we want to ensure safety is that we have to make sure that the supply is isolated properly. So earlier I talked about the SMI diagram. We want you to show all sources of supply. It could be generator source, it could be from the power grid, it could be from your solar PV. All these sources are important because we work on any of this equipment, any of this installation, we have to isolate. Isolate means we want to isolate our supply completely so that we can work on the equipment, work on the installations. So we talk about isolation and switching. So 537.2 talk about isolation, how to isolate all sources of supply. 537.5 talk about functional switching. Because when we use any equipment, any device, very often we need to on off. For example, rating switch. We need to on off as a function. On off the switch. For example, water heater, for example, we on off. So these are functional switching. So for all installations, we must have isolation. We must have functional switching. Now on top of that, we may also have some switching off from mechanical maintenance. You need to maintain a certain pump, for example. Then you need to isolate, make sure you can work on this pump. So you have switching off from mechanical maintenance. And if you're dealing with rotating machines where there may be a danger, then you need to have these emergency switches. So all these are important to make sure that the installation of all these devices, people using, operating this installation, they are protected, they have the appropriate device at the appropriate locations so that they can protect themselves. Now, there's a table in section circuit breaker, you have socket outlet, you have MCB, controller, all kinds of devices. So, which can provide what function? The source of information is this table 53.4. It tells you what this device can do, whether it can work as isolation, whether it can work as a switching, whether it can work as an emergency switching. Right? Because one device can have multiple functions. Same device can serve as an isolation, can serve as a switching. But some device can only have one or two of functions, not all the functions. So you want to understand what are different devices, what they perform, so you can put in the appropriate device at the appropriate location in your electrical installations. Now, come back to my favorite topic, learning. We talk about learning very briefly, learning and bonding are very important. One of the source of working against is that there's a diagram in 1968, just reproduce here. We talk about very details about protected building in floor 1, 2, 1 level. We talk about what needs to be provided protected earth. How to build it? What kinds of earth? As you know, TNS system, there's one earth which is a combination of source earth and installation earth. In the TT system, then you have two earths which has a source earth as well as the installation earth. So under 401 talks about all different kinds of earthing. So it will affect how you provide protective systems in the design. On top of that, you need to have EQ potential or protective EQ potential. So this diagram shows you what is earthing, what is bonding. They serve different purposes, but they must work hand in hand. Earthing and bonding together in order to achieve the automatic disconnection of the protective device within the time limit specified under the 628. So on top of that, under 544, we have one more, which is the protected bonding conductor for main bonding and secondary bonding. So on top of bonding, which is the main bonding, there are also supplementary bonding. In situations where there are extra hazard, in situations where you need to make sure that the potential is as low as possible. So you have a supplementary bonding. So supplementary bonding is not for all installations. There are specific installations where there are particular hazard you need to put in supplementary. So if you do, then you look at 544. It talks about in what situation you need supplementary bonding and how to size the supplementary bonding. What is the size you need to use? On top of your main bonding, on top of your protective earthing, what kind of size of cable you use in order to achieve this supplementary bonding. So, chapter 54 is devoted on building arrangement and protective devices. So, in this chapter, it talks a lot more details about building arrangement. It talks about TNS, the TT system, what I just talked about. What is TT? What is TNS? I'm sure all are familiar. As I said here today, you still don't know what TNS is. Maybe you are in the wrong seminar room, maybe you should be next door. Okay? So, I expect most of you are familiar with this. But refresh yourself because these are important concepts. How do we achieve TT and TNS? What kind of electrodes? It talks about various electrodes in our stable standards. We can use a typical earth rods on top of earth rods. So, on top of earth rods, we have other things. Because sometimes when we achieve the earth resistance, then we need to have some other means of protection, some other means of electrical systems. So we could talk about all this. So under what kind of situations then you can use other types of electrical systems. Building conductors, what is building conductors? So talk about the installation. What is the building conductor? Which is considered as the building conductor. You cannot building conductor all the way. So which is not. How is bonded to MET? MET stands for main electrical and main earth terminal. This is the terminal that you find in every installations. This is the main one. All the conductors which is bonded to the earth through this MET. So under section 543 talks about protective conductors. must make sure that the protective conductor is able to carry the current it's supposed to carry. So when there's a fault current will flow through the protective conductor. So if the conductor is too small, you will not be able to carry the fault. So as I said about how to size it properly. You don't need to precise it, but you must size it properly so that when there's a fault, it's able to clear it. Some of you may be familiar with some equation. This is the equation that you use again. You will not be asked for calculation, but you are expected to know the concept. What does it mean by this equation? What is K? What is S? What does it mean? What is this? What is S? Now, 544 talk about bonding. So, separate to 543 is protective conductor. It goes into details of projective bonding conductor. It talks about main bonding conductor, which is the main one, the bonding to the main of terminal. Also talk about supplementary bonding. So we want to know more because, as I said, you need all these conductors to work together to achieve the magnetic conduction of the protective device. Now, once your installation is complete, design properly, install properly, according to the code, the next one which is important is make sure it's tested properly. Because that's the last step. Before you turn on the supply, or subsequently you want to go back to regular inspection, regular testing, you want to make sure that the installation is still safe. Why? Because it's LEW design, right? You want to make sure that it is still safe for operation. How do you know? Again, as I say, you cannot touch it, you cannot feel it, you cannot smell it. What can you do? You can redo testing. You can do some inspection, do some testing to make sure that the installation is safe. Now, I want to emphasize, the electrical testing by itself is also hazardous. Don't assume that electrical testing only, no danger. I see a lot of accidents occur because the person who conduct the test is not careful. So please, bear in mind, safety is important. Testing itself, how to conduct it safely. Of course, firstly, you have to check whether your instruments are safe, whether it's calibrated, whether there are broken wires, things like that. Make sure your instruments are safe before you need to conduct the test. So make sure that when you do a test, it's safe to do the test. And also, because some tests, you need to inject some current, inject some voltage into the system, you may also cause danger to people who are surrounding. There are people who are near the installation, they are not aware that the instruments will produce some kind of current and voltage. So make sure that these people are protected. They are safe. So when you do a test, bear in mind, you yourself is safe, you're very important. Make sure your equipment are calibrated, your equipment are safe before you proceed to test. And while you're doing the test, remind everyone which is surrounding you. Don't chit chat, don't go and talk about welcome. Make sure that it is safe. Now, there are procedures in the 628. We go into details of part 6. The whole part is on inspection and testing. So I want to highlight 610.1. Precautions should be taken to avoid danger to the person and to avoid damage to property and installed equipment during inspection and testing. So this is important because when you do a test, it will cause damage to the installation. It will cause injury to people who are not aware because they are not LEW. They are helpless. They do not be aware of the danger. You are aware. Once you are aware, you know the danger of testing. So you need to make sure that people around you are also safe. So 611 talk about inspection. Before you do any test, do the inspection first. Because, as I said, testing entails some element of risk, some element which is hazardous. So before you even start, press the test instrument, press the button, check the installation first. Make sure it is more or less safe. There's no obvious danger. There's no obvious short circuit in the installation before you even proceed with the test. So in the 638 talk about a list of inspection, what you need to inspect. So go through the inspection, make sure generally it's okay. Before you go to testing. Testing is this one, chapter 1, 612. And again, in chapter 612, 612.1, the tests are described. And not only that, The order of the test is also important. The code specifically mentioned. That means that you should follow the sequence of the tests. Why? Again, because the test itself could be hazardous. There are certain tests that you need to inject the current, you need to inject the voltage. You must make sure that some basic test is done first. That's why the code say you need to follow the sequence. You know, some of us are very patient. You want to go ahead and do this. You also want to be safe. Be very careful, stay calm, don't rush into the job. Follow the step according to SSH rate. There's a reason why there's a secret in such a way, because the test server can be reduced. Now, the last topic I want to share with you is some temporary stations. As you know, as the LW, you don't only in charge of permanent stations, you're also in charge of temporary stations. What are temporary stations? They are construction sites. People are doing construction. There are some trade fair, Pasar Christmas is coming, New Year coming, there are some festive lighting, and all things like that. LW in charge. And because all these are either an environment which is very dirty, very wet, construction sites, or an environment where a lot of public can access. Children, grandma, granduncle, they walk past, they don't know the danger. So again, it's a duty to make sure that our stations. So how to ensure they're safe? It is described in two codes. These two codes again is a requirement under electricity regulations. SS650, there are two parts of it. Part one is about construction and building sites. Part two is the festive lighting, trade fair, meeting fairs, exhibition sites. So they cover all the others which are easily accessible, which are part two. On the construction site, this is where the environment will shape up, aircon environment, machines, very nasty, humid, and so on. So I combine these two because the concept is quite similar. So in 6.3 of part 1 and 5.3 of part 2, about installation of tensor. As you know, we can take a supply from a generator. If I have a construction site, it's not necessary to take supply from power grid. I can take supply from a generator. Make sure the generator is safe. How to inspect, how to ensure the generator is safe. Again, under 650, there are a lot of requirements how to make sure it is safe. What to look out for in construction sites. As I say, the construction site is where a lot of work, a lot of activities. People are running, people are moving around because of the construction time. People are using all kinds of machinery. Unfortunately, in construction site, it is not a very cozy environment. You don't have aircon. It's always MRD, a lot of water, here and there, a lot of dusty. So how to ensure that our installation is suitable for the kind of environment? So people walk around and get tripped by the wire. Get electric shock because of some loose wire which is damaged because of the truck that ran out of the way. So these are things described in the responsibility. So as an LW, when you do the inspection, what do you see? You're not going to say, oh, this PTO, I need to be ready, I have 1 unit there, I'm going to see. This is not your job. My job as an LW is to be in charge of installation, construction site, and make sure that people, workers, and the construction site are protected against any electrical hazard. So make sure that the generator is safe. Make sure that the equipment is used is proper. Make sure the wire are installed. So again, in part 7, section 776, part 1 and part 2, talk about protection for safety, similar to 6 rate. There are different requirements, more stringent requirements, because construction sites are saying there are no activities. So there are more stringent requirements they are described in terms of basic protection, in terms of fault protections. So go into these two standards, understand what are the differences between 638 and 650. In section 7, part 2 and 8, part 1, talk about how to directly wires the equipment, because these are the cases where you tend to move it very often. Even the generator will inspect today is at that location. Tomorrow, the supervisor will tell you, hey, I want to move to another location because the construction is going to over here. So there will be moving of the equipment quite often in construction sites. So how to make sure where to locate all this equipment, where to locate generator, where to locate the wire, where to locate your SOA. SOA is socket outlet assembly, which is used in construction sites. Where to put them and make sure that they are safe. The generator will install in not topple, some area is topple, some has it. So again, hopefully fast will talk about all these details. How to select and there is a checklist to help you inspect construction sites. So you will inspect, there is a checklist. There are some of them are common sense, but there are some peculiar things for different sites. There are different attention you need to pay to. Right? So go through a checklist. There are certain things you want to pay more attention to that. Construction site is especially more hazardous compared to others. And you pay more attention to some of these numbers and these items in the checklist. Okay, before I end this session, this briefing, just a few things I want to share with you. I conducted some interviews, and I just want to share with you why you want to fail at assembly testing. Actually, I tell you, we are very reluctant. If you want to fail at assembly, you do it very reluctantly. But most of the critical reasons why doesn't fail is that you do not have relevant practical experience. You may have seen other people do it. You think that you are familiar. Oh, I see my workers do it. I know how to do it. But when you actually do it yourself, you may not know. So LEW is very hands-on. It is not some academia through our calculation. It's not there. You need to be hands-on. You need to do it yourself. So very often in the interview, you find out that applicants do not have relevant practical experience. You may be very experienced in selling generator, you are very experienced in selling switchboard, but you do not know how to test it, you do not know how to install it. So that is a part of the selected. Trust us, you know relevant experience. You can find out. You can memorize the whole SS6 rate, there's no use. We want you to be able to apply 6 rate interpretations. Actually, how it's being done. So that is the part I find that some of the people get to. So please try to gain as much practical experience as possible. Try to get hands-on and tell you what they do. Try this once, then you know the difference. Some of them do not have good practice. As I said earlier, beginning before my preview, you want LEW to be very careful, very composed. There's no try and error. As I say, once you're there, you're there and doing decisions. You cannot turn this button, see where they work. Oh, if you don't work, you turn another button. There's no try and error because we're talking about life and death. So we want to be very careful. We treat all the conductors of life first. Before you confirm it is 100%, 200% dead. Okay? Alright. So if you're not sure, sit back, don't rush into it. Sometimes we see some time is precious. I know every hour we spend here 2 hours, it costs you $2,000 a day. Be careful what you do because that moment of sitting back can save you. So, as I said earlier, we have a lot of pressure. LEW is not true. Some people apply pressure on us. Why do you do this so long? I must apply. I want to turn on quickly. Time is the fastest to everyone. For us, life and death is more important. We are no longer here. How do we enjoy the money that we give? So I want you to be careful, think carefully before you work and then you choose structures. Last word for you. The keyword is sense of safety. As an LEW, I'm not expecting you to fire a rocket to the moon. I'm expecting you to be safe. As I said earlier, I hope all of you, after you become LEW, hold on. questions in the survey form, because in the survey form we also ask you if you have some burning questions you want to ask us. I'll try my best to answer it. I saw the questions, most of them ask about what are topics, what we will ask you, things like that, how to cover. Most of them, again, as emphasize, these are important concepts we expect you to know, even before you come to the meeting. Here, I'm not giving you an answer as you know, because it's impossible for me to give you an answer in 1 hour, 2 hours. There are a lot of things in history, there are a lot of things we learn in science. So please get yourself ready, pay attention to those topics I talk about in the interview. We expect you to know all these topics very well. I feel this question I think is very useful, very meaningful, and I would like to share with some of you. There's one question on how is practical tests carried out? What will be tested in practical tests? Please assist how to measure time so that I can complete them. What do I look out for in troubleshooting electrical distribution board? So this one I think is related to electricians and applicants. Technician I say there's no practical test. So electricians I briefly talk about. In terms of practical tests, basically it's a simulation, it's a board, to simulate the electrical installation. There will be some faults in this electrical board. What are the faults? You can find out. Usually those are open circuit, closed circuit, short circuit, some variety, light will become neutral will become earth, things like that. Okay? So if you're experienced, it's okay to do it because you check out the wiring every day. So you should be very familiar. I will say you're familiar less than 5 minutes to finish. Right? So if you struggle to do it, that means that's what I'm talking about. You don't have the practical experience. Maybe that's the first time you do troubleshooting. Means you're not ready for it. What tester do you bring? Okay. You are encouraged to bring your tester because you are familiar. You know what kind of experience you have. So bring along continuity meter, multimeter, bring along a screwdriver, and things like that. In case, just in case, the instrument is faulty, you won't fail you straight away. So even though your instrument is not working, you land it. That is only a large result because of all the known instruments you're familiar. You land the instrument, take half the time to get the instruction manual. So if you really need to, you tell the officer, you can still need to. Which regulations are essential to licensed electricians? What mandatory code of practices and procedures for retrieval, submitting forms, information on electricity? So, as an LW, you must know all the regulations. Just like a license, driving license, you need to know the highway code. So, what the license you need to know? Electricity Act is one of them. On top of that, of course, the regulations which are in the Electricity Act. You have the electrical workers regulations, electrical installation regulations, and also have the electricity licensing of electrical installation exemption notice, so you know which is under the licensing regime, which is under the licensing regime. So these are the regulations that you need to go familiar. And all these regulations can be downloaded from the website. It's free of charge. Why is it free of charge? So that you have no reason to say you don't know. That's the reason it's free of charge. So it's free. You say, I have no money, I cannot pay you for it. That's not the reason. You must know because these are the regulations. So all these regulations is known. And what are the core practices? One of the regulations specified through SS63, which I'm talking about today, 610, part 1, these are the 3 core practices that we need to be familiar. Of course, on top of that, there are some good practice, SS528, 511, things like that. It's also important because this will lead to good engineering practice. But by and large, the important codes are all inside 638, 656. What is the expectation from EMA? What's EMA looking for before awarding the license to us? On top of that, it's very hard to cover all aspects of theory and regulations. In my opinion, these are licenses given to us so that we can assist in the governing and helping of EMA regulation standards. So those are all those questions. I agree totally. As an LW, we are actually assisting EMA to make sure that these questions. So in order to do that, the criteria is basically you need to know what do we regulate? We as people regulate safety. We make sure that installation is safe. So you must know what is safe. Then we will give you a license. Because once you get a license, you become part of EMA. You extend as an extension now. Your eyes and ears of EMA officers look out for the danger in the electrical installations. So you must be very familiar with the core practices. What is stated in the history? What can be done? What cannot be done? What will constitute danger in electrical safety? Because after we have done it, someone is going to use electricity. And these are laymen. You cannot blame them. They are not experienced. They are not competent. So we are there to help them. We are there to protect them. So that's what we do under our subject department, is to make sure that the installation is safe. So I agree 100%. So our expectation is that you're familiar with regulations, you're familiar with core practices, familiar with standards. But on top of that, as I mentioned earlier, I want you to be very careful. I want you to be very calm. I want you to be very composed in all kinds of situations. Even though you are under pressure from your clients, your bosses, your other colleagues, stay calm. Do your job properly. Follow the safety procedures. I attended one interview and I failed. I was told to follow another program in SA. However, I did not have much contact with any of the people. First and foremost, LEW emphasizes practical experience. It's not an exam that we read about the whole score an A in exams. In LEW, we're dealing with safety. So it's not just reading of reports, but understanding what the safety procedures. So I can sympathize this person. I don't know whether it's she has not no opportunity to follow and help. But my advice to the person is that you still need to at least observe how your work will not allow you to do that. Maybe some of your friends, you must know some people to do that. Otherwise, you will be interested. You become influencer. Become richer. Why you want to be LEW? You must have some friends, colleagues, whatever. Find out from them. I know sometimes not easy. Depends on who are your friends. Some of your friends are also trying to do it. So you're finding matcha. These are things I'm going to teach you what to do. So learn from your friends. Go there. Learn from them. How to do it. We also understand this issue here from you. Talk to some of the IHL, SIPG. We want them to introduce some practical sections in the courses of conduct. So SIPG has some methodology course. You will have some practical sessions for you. So for those who are really lacking in practical, you may also gain some practical experience by completing some courses. So go to some IHLs, whether it's Polytechnic, SIPG, ITE. They do conduct some courses with some practical sessions. So you can do some hands-on. But importantly is, you still need to have hands-on. We cannot eliminate this part. This is still very important to us. Is there any plan of LEW for people who are not working in HV environment? For example, some people would like to concentrate to provide services for domestic or small office services. They're not doing any big electrical installation maintenance or factory operations. Okay, now let me just clarify. Licensed electricians and licensed electrical technicians, they are very limited scope to do HV work. I'm not too sure about what this person talk about HV environment. Usually, when you want to work with HV, it must be under the instruction and the supervision of HV switching engine. It's a must. Now, what I share with you is that don't take the instructions as a law, because the switching engineer will be wrong also. So if you are not too sure, please clarify. Accident happened, poor limit, technician get injured. Why are they injured? They're not supposed to go to HV room. They are no instruction. HV engineer say, hey, go to help me do something. Not so sure. Go in, do something which is by mistake, accident. Who suffer? Technician suffer. Although HV engineer is responsible, the instruction to you is not clear. Please clarify. If you are not too sure what to do, ask him, because it's his job. It's his duty to explain to you clearly. his duty and responsibility. He take the responsibility. So if you're not too sure, hey, I don't know how to operate this brand new switch here, ask him. Familiar as office before you do anything. That's what I want to talk about HP environment. You will not do any HP environment unless the equipment pretend there's no supply, there's no danger. HP equipment, HP engineer certified, safe to work. Otherwise, you will not work HP environment. Now, on the second part, we want to concentrate on doing domestic. At the moment, our license allow us to do all kinds of installations, associated with this apartment, offices, shop houses, even temporary installation is allowed. Today, we will not do it. 5 years later, sometime, as you pay, I pay you $10,000 to do it for me. Will you do it? I will do it. Straight away, first one. Pay 100,000, I'll rush to enter, no problem. So, today, we will not do it. License allowed to do it. We will not do it. So, before you take on any installations, the fundamentals are the same. Whether it's a shop house, whether it's residential, the safety is the same. Even in temporary outside, it's more stringent, but the principle is still protection for safety. We talk about basic protection, we talk about fall protection. There's no difference, that's all. What else? No more already. So, you must understand protection for small installation, residential, you can apply other installation. That's why the license allow all the people to cover all these installations. The next question is, I'm a person doing smart home control. Can I apply for the license? So if you are just doing the control part, it means you're doing all the Cat5 cable, control wiring. There's no need to be eligible because these are not considered as electrical work. Unless you need to modify the DB, you need to change the socket wire. Otherwise, just do a smart home control and say there's no need to do for the I like to propose an approach where, in addition to the interviewers posing questions, applicants can also share their experiences, case study, with the interviewers. EMA interviewers can ask questions after or offer challenges related to the case. Simultaneously, EMA can gather information regarding on-the-ground developments with valuable insights provided by applicants. EMA can find underlying issues within the electric industry and improve regulatory enforcement. I think it's a good idea. Most of the time, when we start an interview, we also ask applicants, share with us your experience. What have you done? If there are any challenging case study, you need to share with us by all means. But we are not there to challenge you. We are not there. We will just ask you some questions, and we are not there to challenge you. I'm sure you have your experience. And your experience will be very valuable. It will be different perspective from us. It's okay. Everyone has different perspective. We come from the perspective of a regulator. We come from the perspective of practicing engineer, practicing engineer. It's okay. But we must have a common point, which is how to ensure safety. Whether we're practicing on the ground, whether we're practicing at the same, we share the same view. As I agree earlier on, there's just extension of this. Do exactly what we do. You may be doing more because you need to on the ground, you need to project other things, you need to look at all the commercial pressure, which I don't have to. I don't have to look at the cost. I can say, I must do all this, but at all costs. We have to face this, not me. But the principle is the same. We cannot compromise it. Right? So I think it's a good idea. I encourage all of you to come from you. Share with us. If you have any interesting case study, share with us. Learn something from you. Important thing is safety should be our common ground. All of us should agree on it. Expectation LEW other than technical companies. Again, I just repeat myself. Careful, calm, composure. These are on top of the technical companies. Okay, so now, for the time too much time.